Hello, my dear students. This is Karthik, your maths tutor, heartily welcoming you all to Vista's learning. So, in the previous class, that is class 10, what we have seen in the mathematics chapter is a pair of linear equations in two variables. Correct? Pair of linear equations in two variables. Now, we are in class 11th. So, here we'll be seeing the next chapter in class 11th, which is linear inequalities. Now students, what we saw previously, so there is a connection between this chapter and whatever you have studied in the previous class. Alright, so what you have studied in the previous class, just let me make a I'll write down here. In 10th standard you had studied a pair of linear equations in two variables. Okay, in class 11th what are you studying? So this is what you are studying in class 11. So that is nothing but linear inequalities. Correct. So when do you call a equation an inequality? So for example, I'll tell you. So you have to just recognize and tell this is an inequality, or this is an equation, or this is an expression. So three different terms. The first one will take, so this is, okay, by mistake. So this is here will take expression, next we'll take equation, then let us take linear inequality. So what is the difference here, students? Okay, what is the difference between all these three things? What is an expression? What is an equation? And what is a linear inequality? Alright, so we'll just differentiate it like this. Then we'll start up with this chapter. Alright, so 10th what you studied? Linear equation in two variables. Note this highlighted point, equation. Okay, so what is an expression? So for example, let us take 3x plus 2. This is an expression. Okay, so an expression is consisting of one or more terms with addition, subtraction, division and multiplication between the terms. This is called as an expression, that's it. 3x plus 2 is an expression. Now, what is the equation? 3x plus 2 is equal to 8. This is the equation. Now take this 8 on this side, what will happen? 3x plus 2 minus 8 equals 0. Plus 2 minus 8 is nothing but 3x minus 6 equals 0. See this? When an expression, this is expression, right? Only 3x plus 2 is expression. Now when the same expression has been equated to a number or another expression or 0, then it is called as what? It is called as an equation. Alright. If the expression is equal to another expression or a number, it is called as an equation. Now instead of this equal to, okay, instead of this equal to, if we write like this, 3x plus 2 is lesser than 8. So we are not using equal to, students. Okay, we are using lesser than symbol. Then this is called as inequality. Okay, so linear what is, okay, inequality we got. So what is inequality, students? When an expression with these signs, okay, so this is lesser than, greater than, lesser than or equal to, greater than or equal to. Instead of this equal symbol, if we are using these symbols instead of this equals, then that equation is called as what? Inequality. Now what is linear here then? What is the meaning of linear? So the highest power here, students. So what is the highest power here? 1. What is the highest power here? Highest power of the variable. That is 1 again. Highest power 1. So if any equation or expression which is having the highest power in it as 1, then it is called as what? Linear. If the highest power is 2, it is called as quadratic. If the highest power is 3, it is called as cubic. If the highest power is 4, then it is called as biquadratic. So I'll give you standard forms of all these things: linear, quadratic, cubic and biquadratic. Alright. So this is just an introduction to linear inequalities. So when an expression, instead of using an equal symbol, if we are using these things, so these are nothing but inequalities. So if you use that, then it is called as a linear inequality. Why linear? Power is 1. Why inequality? Because instead of equals to, we are using these symbols. Got it? So this is just an introduction to linear inequality. Here we had studied equation, right? Equation equals to. Inequality, these are the symbols. Differentiation. Okay. So next, So this was just an introduction. Now here we'll see. So two real numbers or two algebraic expressions related by the symbol. So what are the symbols here? Lesser than or equal to, greater than or equal to, along with this lesser than and greater than. So this is nothing but called as what? Linear inequality. So two real numbers. So for example, so in the next slide we have, see that if you have to read this, how do you read? So students, most of them, okay, will get confused with the signs. So for the signs, I'll teach you something here. So now let us take 6 and here we'll take 7. Now should you use this sign in the blank or should you use this sign in the blank? Now see which is greater here students, which number is greater? Obviously this number is greater. So this is greater than this, right? So give it 2 points, okay, give it 2 points and for this give it only 1 point. Now try to join the points. So 7 is greater than 6. So whichever side we have only 1 point, okay, that is smaller, and whichever side we have 2 points like this, okay, that is greater. So you can just remember it like this. All right. So you can make a note of that as well. So here if you see now, how do you read this? So there is only 1 point for 3 and 2 points for 5. So 3 is lesser, only 1 point. 3 is lesser than 5. Is that correct? That is how you read it. 7 is greater, 2 points is for 7, right? 7 is greater than only 1 point for 5. Are the examples of numerical inequalities. So these are numerical inequalities. We are not using equals to, we are using those symbols, right? So it is numerical inequality. Moving on to the next one. X lesser than 5, y greater than 2, x lesser than or equal to 3, y lesser than or equal to 4 are some examples of literal inequalities. So what are literal inequalities? Inequalities consisting of only one variable like this are called as literal inequalities. All right, moving on to the next one. Now see this, how is this read? 5 is greater than 3, 2 dots for 5, so that is why 5 is greater than 3, but 5 is lesser, only 1 dot, than 7. So this is how it is read as. It is read as 5 is greater than 3 and less than 7. Understanding? So what are these inequalities called as? See, this is literal inequalities. These are numerical inequalities. This is called as what? Okay, we'll see that. Next, how do you read this? X is greater than 3 but lesser than 5. Next, y is greater than 2 but lesser than 4. Okay, all these are called, these three are called as what? Double inequalities. Okay, means there is a number. So just try this one, try this. What is x equal to? X should be greater than 3. So that is 4, 5, 6, 7, 8, 9, 10. But x is also lesser than 5. So lesser than 5, greater than 3, there is only one number, that is 4. Similarly here students, y is greater than 2 but lesser than 4, then what is y? Y is equal to 3. Understanding? So these all are what? These all are double inequalities because we have two inequality symbols, right? 1, 2, 1, 2 and 1, 2. What are inequalities? In an equation, if you take out that equal to symbol and if you insert these symbols in there in the place of equals to symbol, then that is called as an inequality. All right. So these are some of the inequalities which we have seen: numerical, literal and double inequalities. Moving on to the next one. So next what we have 10 equations here. All right. In these 10 equations, we are going to classify. So for example, now let us take 1, 2, 5, 6. Okay. So this is one group. We'll write in red color only. These are called as strict inequalities. All right. Next. Apart from 1, 2, 5, 6. Next we will take 3, 4, 7, 8, 9. These are called as slack inequalities. I'll tell you what are the difference here. In the meantime, you can just make a note of this. Okay, strict inequalities, slack inequalities, that's all. So others are there. I'll tell you on this here only. Okay, with the help of this equations. Now here, why are they called as strict inequalities? So if you observe 1, 2, 5 and 6. Okay, see this 1, 2, 5 and 6. Students, either there is greater than symbol or there is lesser than symbol. That's all. See this? So this is lesser than, this is greater than, lesser than, greater than. These are the symbols. And there is no equal to sign here. See, there is no equal to sign here. Only it is greater than, that's all. So since there is only greater than and there is no equal to sign, that is why it is called as what? Strict inequalities. Alright. Now you see these equations 4, 3, 4, 7, 8, 9. See this? 3, 4, 7, 8, 9. What are these called as? These are called as slack inequalities. Why are we calling them slack? Lesser than or equal to, see this equal to sign? I think you can see that, right? Greater than or equal to, see here, equal to sign. Lesser than or equal to, greater than or equal to, lesser than or equal to. So four signs we are using, students. Greater than, lesser than, greater than or equal to, lesser than or equal to. If we are using this, it is called as slack inequalities. Alright? If we are using only this without an equal to symbol, then it is called as strict inequalities. Got it? So that is why we are classifying these as strict inequalities and slack. So here I think I missed out number 10. So see here, it is also having only greater than symbol. So you here also you can write number 10. So 5 on this side, slack, 5 on that side, strict. Alright, make a note of this. You can pause the video. Moving on further. Next. Apart from slack and strict inequalities, there are others also. So for example, now let us write 1, 2, 3, 4. Okay. On this side we'll write 5, 6, 7, 8. And down we'll write 9 and 10. Again classification, have a look at them. So 1, 2, 3, 4, observe them. Only x we have, x we have, x we have and x we have. Only x, correct? Only one variable is there. What is the highest power? 1, 1, 1 and 1. So what do we call this inequality now? Linear. Why linear, students? Power is 1. Inequality. Why inequality, students? We are not using equal to symbols. We are using other symbols. Greater than, lesser than, greater than or equal to, lesser than or equal to. So that is why linear inequality in how many variables are there? Only one variable, right? In one variable. 1, 2, 3, 4 are called as what? Linear inequalities in one variable. Linear, power 1. Inequality, no equal to symbol. In one variable because only x is present. Got it? So as per the equation, we are writing the words here. Moving on further, 5, 6, 7, 8 is called as what? Now observe 5, 6, 7, 8. xy, xy, xy. Then what are ABC then? ABC are constant, students. What are constants again? Constants are nothing but numbers. Alright. Now 5, 6, 7, 8 is called as what? 5, 6, 7, 8 is called as. So what is the highest power here? Power of x, 1. Power of y, power of x, power of y, power of x, power of y, power of x, power of y. So if you see 5, 6, 7, 8, the highest power is 1. Correct. If the power is 1, what do we call? Linear. We are not using equals to symbol. It is called as inequality. How many variables? xy, xy, xy and xy. So linear inequalities in two variables. Understanding? Linear inequality in one variable, linear inequality in two variables. Now see 9th and 10th, students. So here, what is the highest power? What is the highest power? 2. What is the power here? 1. Which is highest, students? 2 is only highest, right? 2 is greater than 1. Same thing here also, 2 and 1. How many variables? Only one variable. Now, highest power is 2. So can we call it linear? No. If the highest power is 1, then only we can call it as linear. If the highest power is 2, then we cannot call it as linear. So what do we call this now? What do we call 9 and 10? So 9 and 10 will be calling them as quadratic. Why are we calling this as quadratic? Because here the power, highest power, okay, highest power equals 2. That is the reason we are calling it as quadratic. Highest power was 1 linear, highest power was 1 linear as well. highest power is 2. Here we'll call it as what? Quadratic. No equal to symbols here, means we are using some other symbols apart from equal to. So quadratic inequality, how many variables? Only x is there, right? In one variable. Understanding. So this, you can make a note. So all the types of inequalities are present here. What did we see for students? Strict inequality, which means only lesser than or greater than, no equal to symbol. That is called a strict inequality. Next we saw slack inequality, which is the combination of greater than or lesser than with an equal to symbol. See this? With an equal to symbol. Okay, combination. That is called a slack inequalities. Next we saw what? Linear inequalities in one variable, linear inequalities in two variables. And the last thing what we saw is quadratic inequalities in one variable. So this is just an introduction, okay, introducing two inequalities. So you know what is the meaning of linear now? Power is equal to 1, highest power. You know what is the meaning of quadratic? Highest power is equal to 2. You know what is the meaning of inequality now? Means instead of equals to symbol, we are putting these symbols. Alright. So this one example is showcasing all the types of inequalities. Okay, moving on to the next one now. So there are some rules on inequalities. So how do we operate inequalities? Alright. So very simple rules, very similar to the equals to symbol, but very small modifications. So what are those modifications? We'll see. Only two rules are there, students. Okay, so we'll see what is rule number 1. Equal numbers may be added or subtracted, both the sides of an inequality. This is important, without affecting the sign of inequality. Without affecting the sign of inequality. Alright. Next, rule number 2. Both sides of an inequality can be multiplied or divided by the same positive number. So students, point to by highlighted. Positive number. Then what is happening if it is positive? No change in sign. Which sign are we talking about here? Which is this sign? This sign is nothing but lesser than, greater than, lesser than or equal to, greater than or equal to. This is the sign we are talking about. No change in the sign. If it is a positive number, and if we are multiplying or dividing, if suppose, but when both sides are multiplied or divided by a negative number, multiplied or divided by a negative number, then the sign of the inequality is reversed. If suppose, now see here, A greater than B. Understanding? A greater than B. Now what will you do? Multiply both sides with minus 1. What will happen? Minus A minus B will happen. Correct. Will it be the same sign? The sign will change. It will become like this. Understanding? So these are variables, right? These are variables. Now let us take numbers and check them out. So if you take the numbers here, let us take A is equal to 5 and let us take B is equal to 3. What is the sign between them? 5 is greater than 3. Now multiply both sides with minus 1. This will become what? Minus 5 and minus 3. Now which is greater, students? Minus 5 is greater or minus 3 is greater? Obviously minus 3 is greater, right? So the sign will reverse. So that is what rule 2 is telling. If both sides are multiplied or divided with a negative number, then the sign will change. If it is a positive number, the sign will remain as it is. So these are the two rules which you have to remember to solve some problems or examples on inequalities. So further what we'll do, knowing these both rules, knowing the types of inequalities, knowing what is linear, all the things whatever we have seen until now let us get into examples. Alright, so the very first example, so solve 5x minus 3 is lesser than 3x plus 1. So we have to solve this now. So basically what we have to do, students, we have to find out what is x equal to. Alright, we have to find what is x equal to such that the left hand side is lesser than the right hand side. So what should we do here? Take 3x on that side. So we are not adding or multiplying anything. So we are just shifting it now. Okay. So take 3x on that side, take minus 3 on this side. What will happen? 5x minus 3x plus 1 plus 3. What is the sign here? Same as it is. Alright. What is 5x minus 3x? 2x is lesser than 3 plus 1 plus 3 plus 1 is nothing but plus 4. Divide 2 on both the sides. Divide 2 on both the sides. Positive 2 students, not negative 2. Divided by 2. Divided by 2. What will we get in the next step? If you solve this, 2 cancel. 2 ones are 2 twos are. X should be lesser than 2. X should be lesser than 2. Then what is the value of x? The value of x can be written like this. X belongs to minus infinity, comma 2. See, how are we writing this? Curved bracket, which means 2 is not included. Okay, 2 is not, see, x is lesser than 2. X can be equal to 1.999999. No problem. No problem. If x is equal to 2, then this will become false. So put x is equal to 2 now here. 5 2s are 10. 10 minus 3 is 7. 3 2s are 6. 6 plus 1 is 7. It is actually equal to, right? But they are telling it is lesser than. Yes or no? So x should not be equal to 2 students. X is lesser than 2. X is not equal to 2. If x is equal to 2, then this is false. X is lesser than 2. Put x is equal to 1 on both the sides. That will become 2. X is equal to 1. So this will become 4. See, now this is greater than, RHS is greater than LHS. So we have to find out the value of x. So what are the values of x? From minus infinity to 2. But are we including 2? We are not including 2. That is the reason we are writing a curved bracket. If suppose we are including 2, then how do you represent? X belongs to minus infinity to 2 with a square bracket. What is square bracket representing? Square bracket is representing that we are also including 2 as x. If I am writing a curved bracket like this, means we are excluding 2. Now, how is this graphically represented? This is graphically represented like this. This is minus infinity, okay? Minus 3, minus 2, minus 1, 0, 1, 2, 3, and this is plus infinity. Alright, so graphically how are we representing this? This is graphically represented how? So that is a number line, correct? On that number line, are we including 2 students? See here, I am writing x is not equal to 2. If x is equal to 2, then these both equations will become equal to each other, which means the given inequality is wrong. So x is lesser than 2, right? So we are not including 2, we'll put a 0 there. Means we do not want to. And write it like this. Okay, like this. This means what? X is belonging to the set of numbers from minus infinity to 2, where 2 is not included. That is why curved bracket, graphically written like this, or it can also be written like this, x lesser than 2. All the 3 means the same thing. Now, how do you represent this on the graph? Where we are including 2. Okay, so to represent this on the graph, this is minus infinity, plus infinity, minus 2, minus 1, 0, 1, and 2. Square bracket means what? So how is this inequality written? In the terms of inequality, this is written like this. X is lesser than or equal to 2. Means x can be equal to 2 or it can also be lesser than 2. So how do we represent this on the graph? So here you put a 0, right? Same thing, put a 0, but shade that 0 inside. Okay, shade that 0 like this. Which means what, students? We are including 2. Here we are excluding 2. We don't want 2. Here we are including 2. Then show it like this. This is how this thing is graphically represented. Okay, this is not the answer, but this is the right answer. You can make a note of this. Alright, so you can pause the video, make a note of this. This is the very first example. Moving on to the next example. Same thing. So 5 minus 2x divided by 3, read this, lesser than or equal to x by 6 minus 5. So what we'll do here first, students, we'll solve the right hand side. See, left hand side is pretty much solved. Common denominator for both of them, so that is fine. Right hand side, what is the denominator here? Here the denominator we have is 1. So take the LCM on the right hand side, write this as it is. 5 minus 2x, the whole divided by 3 is lesser than or equal to, take LCM, x minus 30, the whole divided by 6. Denominators 3 and 6, 3 ones are, 3 twos are. Cross multiply, 2 of 5 minus 2x is lesser than or equal to x minus 30. Multiply inside. 10 minus 4x is lesser than or equal to x minus 30. 4x will get it on this side, minus 30 will send it on that side. So 10 plus 30 lesser than or equal to x plus 4x. What is 10 plus 30? 40. This is lesser than or equal to x plus 4x is nothing but 5x. 5 ones are 5 eights are. What did we get? X is greater than or equal to, correct? X is greater than or equal to 8. Which form have we written this answer as? The answer is in the form of inequality. How do you represent in? So x belongs to greater than or equal to 8, right? So greater than 8. So this is wrong. Okay, this should not come. We are including it because equal to 8, right? We are including it. So we have to put a square bracket there. Square bracket means we are including 8. 8, comma, after 8 greater than 8. 9, 10, 11, 12, 13 until infinity. Put a curved bracket. Why are we putting curved bracket here? We don't know which is the biggest number. So we don't know, right? Numbers are infinite. So we are putting a curved bracket. This can also be graphically represented as, okay, a number line, minus infinity, minus 1, 0, 1, 2, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is plus infinity. X is greater than or equal to 8. So how do you do that? We are including 8, right? So put a circle on 8. We are including 8, so hatch it. And you can show it like this. All the 3 answers, whatever I have written here, okay, in different forms. This is right. So did you understand the rules of inequality? Correct? You understood the rules of inequality. By using those rules, we have to solve the problems like this. And also, further what we'll be doing, also we'll be representing it on the graph like this. Graphical solution. Okay, this is inequality solution. Alright. So this is also important, students. Very simple. If you hatch it like this, you're including that number. If you're not hatching it at all, then you're excluding that number. So you can pause the video here, make a note of these symbols, notations, graphical solution, inequalities, everything. And I think here we'll be stopping the class, students. So this is just an introduction. We have seen the rules of inequalities, also solved from a couple of examples. All right. So we'll stop the class here. I'll be meeting you in the next session with the next topic. Until then, take care and subscribe to Vista's Learning. Thank you.